You may notice that at this time we are skipping chapter 2. We will potentially come back to it if there is time. We are moving on to chapter 3. Once again, I have some words there for you to potentially define, and I would say of the three you see there, parallel lines, skew lines, and transversal, the one that you might know is parallel lines. Anybody want to give it a shot? Okay, lines that never intersect. We're going to get a little bit more specific than that. Yes? You could put it that way, lines that have the exact same slope. There it is. Sometimes the smartboard does save things a little weird, so it ends up somewhere else. Two lines in a plane. So they have to be in the same plane that do not meet or intersect. That's the only thing more specific we're going to get at this point. But it is correct that they will have the same slope, and we're going to talk about that later this year. But they must be in a plane. So we're going to maybe they're both on the smartboard. That would be an example of that, or both on your paper. That might give you a hint as to what skew lines are. Skew lines are also lines that are never going to hit, but yeah, different planes is really what we're talking about. Let's see how much fun I can have finding this one. Two lines not on the same plane that do not intersect. And what we're talking about there is perhaps I have this line that's on the smartboard, and then think of the marker as it's coming towards the smartboard as being another line, and then maybe it went through right here. Do those lines ever hit? If it goes through that dot, this marker? No, those lines would never hit, but are they on the same plane? No, do they hit the same plane? Yes, but are they on the same plane? No. Big difference, all right? So that's two important ones to discuss. And transversal. A line that intersects two or more lines in a plane. Or more, it's important to know or more. So for example, if I had that line, and perhaps I had that line, this line cutting through could be considered a transversal because it's hitting two or more lines. Any questions on those three vocabulary terms? All right. Everybody's got them down? Well, in looking at these, we see line L, M, and T. Technically, they could all be considered transversals because you agree L and M would hit each other somewhere off the smartboard. So then would they all be hitting two or more lines? They would. But in this case, we're going to consider, based on the way I numbered the angles, that T is the transversal of most importance to us here. Does it look as though L and M are parallel? No. Are they skew? No. They're just two lines just kind of hanging out, right? And T is cutting through both of them, so that's why we're going to consider that transversal. Now, please keep in mind your transversal is not always going to be named line T. So as I look at this, if T is the transversal that we are concerned about, we can name all these types of angles. Okay? And look at it this way. If T is the transversal, we're using these two lines. And you notice the first two words we have there are exterior and interior. Well, in general, those words mean, well, exterior means outside, right? And interior means inside. And so if we're looking at these two ones that I traced in red, are there some angles that are kind of in between those two and some that are not in between those two? Yeah, and those are your exterior and interior. And so if we look at this, exterior angles are the ones that are basically not between those two red lines. So would angle 1 be a possible exterior angle? Yeah. So you just got to start listing them. How about angle 3? Is that a potential exterior angle? No. So another one then is angle 2. How about angle 5? Is that a potential exterior? No, it's in between those two, so it is interior. And so if we keep going, another one is angle 7. Are there any more, or have we listed them all? Yes. Angle 8. Very good. So those would be considered exterior or outside those two lines. Again, if we start talking about a different transversal, all these answers, well, not all of them, but some of them will start changing. Well, so of the 8 that we have numbered, you've said 4 of them are exterior. So logically, the other 4 will be interior. And let's see if that makes sense. So 3, 4, 5, and 6, do those both seem to be between those two lines? Yes, they do. So any questions so far? No? All right, consecutive interior angles is the next one that we have to take a look at. And you notice that it has to be interior angles, correct? So basically, if it has to be interior, the only ones I could possibly use are those 4 that I just wrote. So let's face it this way. If they have to be interior, I better not be saying 1, 2, 7, or 8, because they're exterior. But what do you suppose consecutive means? You could look at it many different ways. But what it means here is if I did the transversal in blue, you have to take 2 of the interior. It's a pair is what it's called. You have to take 2 of them that are on the same side of the transversal. But they have to be interior. So do you agree 4 is a possible interior angle? So to be consecutive, I have to find the one that's on the same side as the transversal. And the only option is 6. So you put these in pairs. So it's angle 4. You can write and if you want, probably better. The reason I don't want to put a plus sign in there for and is then you might think you have to add the 2 angles together, which is not necessarily what we're talking about here. All right. So 4 and 6 are a consecutive interior angles. It's a pair of them. Are they the only 2? No, there is another pair, and that would be angle 3 and angle, again, it has to be interior, is 5. Because again, if you look, 3 and 5 are both interior, and they are on the same side of the transversal, consecutive. It doesn't mean that the numbers had to be consecutive, like 3 and 4 and 4 and 5. All right, it's just as far as consecutive here, it means they are on the same side of the transversal. So consecutive interior angle is one of the special angle pair names. Okay, that's what it's called. Obviously, these other 3 here are the other ones. So alternate interior angles. So once again, they must be interior, right? So you really, so far, only have 4 to choose from. All right. And so once again, they do have to be interior, so I only have 3, 4, 5, and 6 to work with. But they have to be alternate. So not consecutive, but alternate would mean they have to be on opposite sides of the transversal. But there's more to it than that. For example, let's start with 4 again. Well, aren't there 2 angles that are on the opposite side of the transversal? 3 and 5, right? How do you know which one you want? Yeah. Okay, it kind of has to be on the other line as well. And look at it this way. You already have a name for 3 and 4. They're a linear pair. So are we going to give it another name? No. Mathematician's lazy. We're not going to give it a second name. Are you kidding? All right. So 4 and 5. Well, if 4 and 5 are alternate interior, then 3 and 6. Because those are interior, but they are also on opposite sides of the transversal and are not already named something else, a linear pair. The next one's alternate exterior. So the answers have to be exterior angles, which means I better use the exterior angles we listed above, which are 1, 2, 7, and 8. Do you suppose alternate means the same thing it meant just a second ago? It does. It means the exact same thing. So they have to be on opposite sides of the transversal and basically not already named. So one of them is an option. So is 1 and 2 a good answer for alternate exterior? No, because 1 and 2 are what again? Yeah, a linear pair, right? So it's 1 and 8. Very good. That's a little bit harder. That's quite a ways away, right? 1 and 8, but that's still true. Well, if 1 and 8 count, then 2 and 7 must also count. So any questions so far? So we've talked about 3 of the 4 special angle pair names. The last one is corresponding. I saved that one for the last because it is often the most confused. But do you notice the difference between that one and the other 3? It seems to be lacking something the other 3 have. The other 3 specify either interior or exterior, correct? Corresponding can't do that. because you're going to pick one interior and one exterior. I look at corresponding as basically saying they're in the same location. And I'll explain what I mean by that. Let's get this stuff out of here. For example, let's say we're talking about 2. Do you agree in this grouping up at the top, it's kind of on the top right? Do you agree with that? So you go to the other grouping, which is 5, 6, 7, and 8, and which one's in the same spot? Or in the corresponding spot? Or top right is 6. Do you agree? One of those is interior and one's exterior. Okay? And that's why corresponding can't list it that way. So it's angle 2 and angle 6. Another difference is that these other special angle pair names only had 2 pairs. This one's going to have how many? How many pairs can I list for this one? I can list 4 pairs. All right? So we got 2 and 6. So let's shake it up a little bit. Let's go to 3. 3, and that's bottom left, right? So 7. And 8 and 4. Okay. And there's only one left. So any questions on that? I think there's probably a couple good ones at this point that you could ask. Aren't there some angles we haven't paired together? Actually, like 3 and 4 we haven't, because that's a linear pair. How come we haven't paired 3 and 2? 3 and 2, 1 and 4, 5 and 8, 6 and 7, they're vertical. We've already given them a name. Those are vertical angles. And then there's another bunch that we haven't really paired, and that's I don't know, 1 and 7, 2 and 8. You agree that we haven't paired those? What would you call those if we did pair them? Exterior is good. Whoop, somebody said it. Consecutive exterior. Okay, it's not one of the special angle pairs that this particular textbook talks about, but do you agree that could be one? Consecutive exterior, right? 1 and 7, 2 and 8. Okay, it's not one that they talk about. They talk about these 4. Consecutive interior, alternate exterior, and corresponding. Okay, so make sure you know those. Any questions? No? All right. And that's a blank page. So, for those that are listening to the recording, the rest was done on an overhead. So you will have to get those notes from somebody else.